Hi Sculpfun friends, I decided to create this video as my answer to repeated questions regarding laser enclosures which are on the official Sculpfun user group on Facebook. I started with a no-name laser machine and later I have found Sculpfun, which was miles ahead and which is miles ahead in power quality and support. Uh, I have also found that some kind of enclosure is absolutely must-have item unless you want to get a smell which is good for salami but not for human being. For each Sculpfun I have created a new enclosure and tried to avoid the drawbacks I found on older ones. So currently I have already fourth machine, third Sculpfun. Sculpfun S30 Ultra 33 watts and I'm very happy with it. But during cleaning lens after a bigger job I was preparing some Easter decorations for children's workshop held in our village. I have discovered that also internals of laser head are full of dust and I started to think how improve my enclosure and protect my Sculpfun. Target was clear: get clean air from outside for laser head cooling. Dust collected on internals will degrade cooling efficiency and may shorten life both laser diodes and electronic components because of bad heat dissipation. It was clear that there must not be any forces influencing laser head during moving, not for movement or not for weight. If you want to know how I solve it, this video is for you. I have to say that my solution is based on material, on some leftovers from my home workshop. Of course, I had to buy some items, but in total it did not exceed $300. No special equipment or special tools are needed. There are some 3D prints. Definitely somebody can print it for you. And if it can help you to build your design of enclosure, I will be glad. And you can leave a comment, not for me, but also for others, to get experiences from the group of Sculpfun users. So take a seat. We are rolling. My idea was to create space under working area to create downdraft which would take all smoke immediately away from processed material. Take a box with a lid hanged on hinges. Create empty hollow space below. LED, there be light. Create holes for incoming air but not allowing any reflected laser radiation leaking. Put ceramic tile on the bottom as fire and reflections protection. So if you cut through your material, there will be no problem. So air can get in through intake holes and wash away smoke from engraving or cutting. Smoke goes through bottom hollow space and is drawn by exhaust fan. Certified laser safety window is enclosing lid protects your eyes. There are ceramic tiles at the bottom as they are non-reflective and perfectly fireproof. They are just laid in place and therefore easily exchangeable if needed. Each tile is 30 by 30, so layout 2 by 2, 60 by 60 will cover working area. I welded a support ridge from steel L profiles and a fixed steel grid on the top of that ridge. Grid itself covers the whole working area. Because mechanical frame of laser machine is a little bit bigger, there is space around working area, exactly same height as grid itself. In attempt to distribute exhaust airflow, I created some channels under back cover. It also serves as a mechanical stop for inserted exhaust tube, small notch in the hole. Tube is extended at the top to fit exhaust fan inlet. Similar extending funnel was needed for a laser fan to convert small fan diameter to something bigger. 3D print can help. Intake for laser fan should be protected against any objects falling inside. In this case, it will also hold flexible PVC tubing. Diameter is designed to fit tubing. Both tubing and protecting grid are secured by tightened clamp, also 3D printed. And this is diameter converter for laser head. Notice that it's not coaxial, as we need some free space for electric cabling. Bottom diameter fits laser fan, top diameter is 75 mm, so 100 mm tubing is squeezable. Fixed by 3D printed clamp again. Spring wire inside PVC sleeve keeps round profile of tubing during moving. This is exhaust fan for nominal diameter of 100 mm with airflow of 250 cubic meters per hour. As air tubing is 75 mm, real air volume will be a little bit less, but still enough. As it is held by clamps, it can be easily removed for cleaning. It is connected by plug and socket for easy disconnecting. Because my air duct is quite long, I've installed auxiliary fan on upper floor, salvaged from faulty mobile air conditioning unit. To avoid extra cabling, I use RF remote button and RF relay. There is a lot of switches: laser, interior light and exhaust fan. Most left is important main power switch, double pole switch which disconnects both live and neutral lines to avoid any power supply pulses due to leaking current or switched power supply. Electricians will know what I mean. Almost all materials are leftovers from my home workshop. Primary target was functionality, not design. Bottom and side walls are made from 18mm MDF. Top and lid are made from 4mm laminated flooring. Orange plexi in the lid is certified laser safety window with optical density 6+ for a wavelength of X30. As it is little bit expensive, it is protected by normal 2mm clear plexi from both inside and outside. This plexi can be easily exchanged if will be scratched. Therefore, I can safely operate laser without protective eye shield on laser or goggles. So thanks for watching.